regular hexagon there, is that right?
Yeah.
Awesome. Okay, so it says to find the area of the following figures. The hexagon's a kind of a really interesting shape because it ends up being composed of six equilateral triangles. You probably know that if you've seen that in class. And they're giving you one of the sides of the equilateral triangle there, okay? And there's a couple of different formulas that you can use to do this. I mean, one is the area is like 1/2 the apothem times the perimeter. I prefer to find the area of the triangles and then multiply by 6 because I think that's a little more intuitive. I can't really tell how you're doing it here. It does look like maybe you're using one of the the general formulas for an equilateral triangle, but one of the nice things about an equilateral triangle is when you drop this hypotenuse down, I'm sorry, this altitude down, you get a right triangle. So these are 11. And then do you remember the degree measure in an equilateral triangle?
Isn't it like, no, I don't remember.
So all the angles are the same. So let me actually back up here. So in an equilateral triangle, all the angles are the same. Okay.
Mhm.
And then when you drop this altitude down, which you can know if you want, you end up getting a 30, 60, 90 triangle. That's 30 degrees, that's 60, and then obviously that's 90. The altitude also splits this in half. So the base ends up being 11. And then there's a relationship here with 30, 60, 90 triangles. Have you seen that in class?
No.
No. Okay. So that would have been covered under like special triangles with right triangles here. You can use trigonometry. Is that at all what you're using here? Sine, cosine, tangent?
She's talked about that, I think. But
Okay.
mainly we use 1/2 times the apothem times the perimeter.
Got it. Got it. So and that's the issue here is like, how do you find the apothem? Because if you don't know that it's a 30, 60, 90, you're kind of stuck. Now, you know, the shortcut here is that 30, 60, 90. So let me just give you that for the moment here. So it becomes 11 square root of 3 as the height here, or the apothem. Okay. And then, like you said, it's 1/2 the apothem, 11 square root of 3 times the perimeter. The perimeter is 6 times 22. Are you allowed to use a calculator in this class?
Yeah.
Okay. So you would just substitute this into your calculator and determine, you know, that value.
Where did you get 11 in cosine 3?
Square root of 3.
Yeah.
You know, that's again, that's this special triangle stuff that, like, I'm looking at your notes here. You've got a square root of 3 kind of in there. In all the other problems, though, it looks like they give you the apothem or a way to find it from there, because it's a hexagon. That's why this works out nicely. It's only for hexagons. So maybe we should do like 5, the pentagon problem, to kind of better illustrate that. I'm sorry I didn't really answer your question. It's one of those things where I think you probably saw it in class, but you didn't get very many exercises on it, so it's not very clear at this point.
No, I get it. Thank you.
Okay. All right, let's look at number 5. Is that okay? All right, so for number 5 here, this one is better because they're giving you more information. Okay. They're actually giving you the apothem, which is great. That's 8. And they're giving you enough information in this right triangle, which you've drawn here, which is really helpful. They're giving you the hypotenuse and one of the legs, and you're calling it x. The only way to find the third side on the right triangle is to use the Pythagorean theorem here. So just as a reminder here, the legs are a and b. The hypotenuse is always c. A squared plus b squared equals c squared in this problem here. So it looks like, let me just take a look here. Looks like you found x. You did this calculation. You went 8 squared plus x squared equals 19 squared. And you solved for x and got x equals 17.2, we'll say. Okay. But the thing is that's only part of the side. Like, you have to remember to double it to get the full side length there.
Yeah.
So sometimes it's good to actually write like, okay, S is 2 times 17.2 or 34.4. And then you can find the area. It's 1/2 the apothem, which is 8. And then the perimeter is 5 times the 34.4 there. And let's see what you've got there. You've got 172.3. That looks pretty good. You have a question mark next to your answer. Were you unsure, or were you just waiting to check that? What
I was unsure, but I know that that answer is correct.
yeah, that looks good to me. Okay, so like like eight's really similar to that, but it looks like maybe 7's the next one to go to.
7 and 8, I both got wrong.
Okay, so let's take a look at 7. I'm gonna redraw just because there's a lot of
Yeah, it's a
marks
little
there.
messy.
That's okay. No, sometimes they don't give you enough room on the paper when you're trying to work these out. It's
Yeah.
a little bit unfair. So equilateral triangle, it looks like they're telling you that one of the sides is 13. Is that right?
Yes.
Okay. And then the teacher is giving you that this altitude is 10. Is that right?
Yeah.
Okay. Now, it looks like, again, you're using Pythagorean theorem to find the leg here. So sometimes it's good to redraw the triangle that you are trying to find the missing side of 13, x, and 10. And you've done this correct. You wrote 10 squared plus x squared equals 13 squared. That's totally correct. And then x equals the square root of 13 squared minus 10 squared. Your number looks correct here. Let me just double check that with a calculator.
Mhm.
Not sure where a mistake might be. So you got 8.3. One of the things that's kind of bothersome for me here is that if it's an equilateral triangle and you got 8.3 here, right?
Mhm.
All the sides should be the same. So that means that this whole thing should be 13.
Yeah.
And if you double 8.3, you don't get 13.
Yeah.
Which leads me to believe that this 10 is not correct. Now, did you draw the right triangle in or the right angle in, or was that there from
That
the
was just
beginning?
there.
Yeah, I can see. Yeah, I see that. I agree. Any chance the 10, is there like a dot there? I can't really tell.
Yes.
Any chance that 10 is like part of it?
I don't know.
Okay. Sorry. These are sometimes questions I have when I start out with a new student because I just don't know what to make of it. All right. Okay, let's do this problem slightly differently. Is that okay?
Yeah, sure.
Okay. So we kind of looked at this earlier. I redraw it here. If the hypotenuse is 13, this length down here is also 13. Okay. And
Mhm.
that means that this is 6.5. Okay.
Yeah.
Now, if we wanted to find the height, you can use the Pythagorean theorem. It's also a 30, 60, 90 triangle. So the shortcut here is to multiply by the square root of 3. It only works in 30, 60, 90 triangle. You can use a calculator on that if you want. Now to find the area of this triangle, it's 1/2 base times height, and you've seen that before. The base though is the entire base, which is 13. Okay. And then the height here is 6.5 square root of 3. Now you've also written the kind of the known formula here, which is the square root of 3/4 times a squared. We're going to compare that to this, but you'll see that this ends up working out nicely. Do you have a calculator handy?
I don't.
Okay, that's okay. So I'm going to multiply this out. So this ends up being 42.25 square root of 3, or if you multiply by the square root of 3, you get 73-ish, we'll say. Okay. And then
Mhm.
were you given that square root of 3/4 formula in class?
I saw it at one point, but I just looked that up to get it.
Okay. Okay. So the area of an equilateral triangle is like it is a known formula, like you can use that like on standardized tests, that would be a good thing to use over a squared. A is one of the sides, so it ends up being the square root of 3 over 4 times 13 squared like that. But I guess, again, I'm making a little bit of a jump here. You wrote 43.3. It's definitely not that. But the thing that I don't like is I don't know why that 10 is there. So, you may want to ask, your instructors, say, hey, I was working this out at home. I know that all the sides have to be the same if it's an equilateral triangle. I know that this can't be 16.6. It's got to be 13. But this is the correct answer here for that. Any questions on that, or?
No.
Okay. So are these like corrections, or are you do you retake this? What's the
I'm just kind
situation?
of like catching up on old assignments.
That's right. That's right. Mom mentioned that. Okay. Okay. Number 8. Is that right?
Yeah.
Okay. So I really like what you've done here. This is always the way that I show it here, where you actually indicate what it is. It's the circle minus the hexagon. Okay.
Mhm.
And that's really important to do, because then you don't mistakenly use the wrong formulas or anything like that. In terms of the image here, you're given 2 of the sides of the triangle so that you can find the third side of that pretty easily. So let's, and you've got pi r squared here. What did you use for the radius? Let me take a look at your notes here. You used 4. Good. Pi r squared. So that's fine. For the hexagon here, you want to use the apothem times the perimeter, like you said earlier. Okay.
Okay.
And the
When do
apothem,
we,
go ahead.
oh, sorry. When do we know when to use that formula?
The answer is based on what you're given. So in this case, you're given the apothem. Okay.
Mhm.
So that's a pretty good indicator, but it means you have to calculate the perimeter.
Uh-huh.
And generally use it for, I think maybe this is what you're asking. I mean, you generally use it for hexagons, pentagons, all the gons basically. Yeah.
Okay.
So because you wouldn't use it for a rectangle, you know how to find the area of a rectangle, but anything that has this sort of shape to it. All right. So then the part that you have to find here is that third side. So we'll call that x, 3, and 4. So you've got x squared plus 3 squared equals 4 squared, and x ends up being the square root of 4 squared minus 3 squared. Let me give you that number here to a couple of decimal places. Looks like it's square root of 7. So if you're ever working out problems and you don't have a calculator handy, I really like this one that I just dropped in the chat. It's the Desmos Scientific. You enter this stuff basically the same way you sort of write it, so it makes it easier to use. It's also available as an app on your smartphone. Okay, so that's x. So to find the perimeter, that's the side length is 2 times x, so it's 2 times that number. Is that clear?
Yeah.
Okay, and then we now have everything. Pi, the radius is 4 squared, minus 1/2, the apothem is 3. The perimeter is 6 times this S value, which is 5.2915. Whenever you're doing problems like this, it's always good to do the calculation twice, just
Mhm.
to make sure that you've entered everything in right. Now, what I'm going to do here is use that Desmos Scientific so you can see how to enter it in case you want to look back later at it.
Mhm.
And let me snip that in. Okay, so here you go. See how you basically enter it in the way it's written
Yeah.
makes it very, very easy to use. So this is the first problem where I believe we've had to put units in. All the other ones didn't seem to have units for whatever reason. But your area would be this number feet squared like that.
Mm-hmm.
So I'm sure your area of your circle is correct. Looks like the area of your hexagon was the one that didn't go right. I mean, it looks like you tried to use the equilateral triangle formula. Multiply it by 6, maybe. Anyway, any questions on that before we move on?
No.
Okay, so should we go to number 9?
Oh wait.
Or do you have 9, 10, 11?
Can we do 12 and 13?
Sure. I don't see a 12 actually. I just see
Okay.
13.
Yeah, the part where it says 13, that's actually 12.
Okay.
She like
And-
messed it up.
No big deal. Find the area of the shape, then B. The solid it would create if it rotated about. All right. So we'll just do the one on the left here. Let's see, because your work looks fine. Let's see here. Okay, so this one on the left here is a triangle, and they're showing you this axis of rotation. You actually do this again in calculus, which they sometimes review this a little bit. But you got this right. It's a cone, 1/3 pi r squared h. I would like to see, the word cone somewhere. That's always nice to see, but not a big deal. The radius is 3. That looks good. The height is 4. I'm not, I'm struggling here. Like, your answer appears to be correct. Do you have any, I mean, it's just been marked off here. Do you know any reason why?
I don't know why, but it could because of how like I rounded maybe.
I mean, it looks pretty good to me. Let me see here. Find the area. Okay. So here I'm looking at the instructions now. All of this that you did is part B.
Oh my gosh.
Part A is to find the area of the triangle. Yeah, 1/2 base times height. So one of the things I sometimes do for tell students to is like, you got to almost underline or box in each of the parts to know that you've done it correct.
Mhm.
Yeah, it looks like your teacher's very specific. They're like, hey, if you don't do it exactly the way I want, we're not going to give you full credit here. So it's
Mm.
like you have to have that answer and then this answer, like you have to say, all right, that's my answer for part A, that's my answer for part B.
Okay. And I think that completes this worksheet.
How about the one on the right there?
Oh, yeah, that one too.
Yeah, and it looks like the same thing. Looks like you did part B, but not A. Even
Yeah.
though to do part B, you really need A, but sometimes this happens. So base times height, 3 times 4. Yeah, there you go. There's part B. All right, so look, because 14 is looking pretty good here.
I got that one right.
Okay. All right. Okay, so Mom sent over a Word document that I've got here. Is that something else for us to go through today?
Yeah. Sorry, I
Okay,
was yawning.
no problem. It's math on Saturday. It's not the most exciting thing in the world. But it's only a half hour here, so we'll be on to something else in no time. Okay, so here's the first problem that I'm seeing. Is that
Mhm.
right?
Yeah.
Okay, and it looks like you're entering these into some sort of online thing. It says do not type units. I'm actually just going to copy this over one more time here. So there's kind of 2 ways to look at this, and both are correct. Some people visualize it as a cut there, and some people visualize it as a cut there. Which do you
I
prefer or
visualized it as the one on the right.
on the right? Great. So let's take a look at that. And the idea here is you could come off to the side here and redraw them, which is, I like the strategy here, and you label the sides that you know, but then you're obviously missing, you're typically missing one or more of them. Could you tell me what this height is of the,
4.
it's 4, okay? And so you multiply them together, 52 and 42, you know, if you got to show your work, you know, you get 52 plus 42, which equals 94. Don't enter your answers, but it's good to know that it's centimeters squared. Any questions on that?
No.
All right. All right, so this will probably be our last question for today. Find the value of H and the area of the triangular base figure, given the volume of the triangular prism is, okay, blah, 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 right. First thing, first thing here is probably to draw the triangle. And even if you don't agree that it's like where the right angle is, I mean, it's still good to sort of just go with it. The base is 6, the height is 7. So the area of the triangle is 1/2 base times height. 1/2 6 times 7 ends up being 21 there. Okay, I'm just putting the numbers into the formula, no big deal. Part B is a little bit more involved here. It's a triangular prism. There's a couple of different formulas for it. I always prefer to go with the volume of a prism is the area of the base, because the base could change. In this case, the base is a triangle. It's the thing that it's sitting on, times the height. Okay. And good news is you already found the area of the base. You already found that the area of the base is 21. And they give you the volume. So you have 2 of the 3. 189 equals 21 times H, divide by 21, and you have your answer, which ends up being 9 meters. So it worked out really nicely. It doesn't say to round or anything like that. So when you don't get any instructions for rounding, usually you have a nice answer. In this case, it worked out perfectly. All right, so we're going to go ahead and just stop right here.